Hello, so you're watching my channel Kalike, and in the first series you know that I have taken up numericals from mechanics, from the chapter motion in a straight line, and most of the numericals I've picked up from the ncert syllabus. And this is one more numerical that I'm going to solve. Now if you want to see more videos, or if you want to get notified of an upcoming new physics numerical video or anything that is on the physics concept, please subscribe to my channel ASAP and press the bell icon. Okay, so let's get started. The question reads as below. A ball is dropped from a height of 90 meters on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between t is equal to 0 to t is equal to 12 seconds. Well, when you read the question, it appears to be a bit complicated, but it's not if you if you draw a proper diagram depicting what is given in the question. So the question has, you see, let's say this is the, how do you start? So to start, I will write an appropriate diagram of the situation given in the numerical. So let me assume this is the ground level. Okay, so this is the ground level, and let's say this is where from the ball is dropped, which is at a height of 90 meters. So I call that x0 because that is where the ball is dropped from. So x0 is 90 meters. X is the ground level. I call that to be at 0. The ball has an initial velocity of definitely v0 is equal to 0 because nothing has been mentioned. So we assume that the ball has been released from rest, right? So now the ball has been released from this position. So it will experience an acceleration which is given by minus g, right? Now the ball hits the ground. Now before hitting the ground, it will have some final velocity which we are unaware of. We need to calculate. Also, we do not know the time the ball takes to reach the ground. So there are two unknown quantities, the time it takes and the velocity the ball reaches just before hitting the ground. But you have another information in the graph which says that every time the ball hits the floor and rebounds back, it loses 1/10 of its speed. Okay, so if v is the speed of the ball and we find it out, the next time the ball rebounds from the ground and reaches the maximum height position, at maximum height position the velocity of the ball will be 0. Similarly, we also don't know what time it would take to reach, right? So here the rebound velocity, if I call it as VR, is, it says that every time it rebounds it loses 1/10 of its speed. What do you mean by that? So if v is the speed, it loses v by 10th of its speed. So your rebound velocity, which is also nothing but the initial velocity of the ball when it rebounds, should be equal to v minus v by 10, which is nothing but 10v minus v divided by 10. So 10v minus v should be 9v divided by 10. So this becomes your initial velocity when the ball hits the ground and bounces back. Similarly, the ball also travels in this direction, and then if you know this speed, you can easily calculate the time it takes to if you know this time, you can easily calculate the time it takes to reach the ground. So you can calculate the velocity just before reaching the ground here as well. So here also, here anyhow it's v was 0, right? So here also you can calculate the rebound velocity. v0 will be equal to 9 by 10 of v. So this is what is given in the numerical. Now first, I'll just take this information. I know x is equal to 0, x0 is equal to 90 meters, v0 is 0. A is a standard value which is minus g, which is minus 9.8. Time is unknown, v is unknown, right? Now I have an equation of motion that connects x, x0, v0, a and t, right? Where all the quantities are known and t is unknown. So I make use of that in order to find out the time that it takes to hit the ground. Now when I calculate t, after calculating t, I will use the value of t and find out the value of velocity or speed with which the ball would just reach the ground, or before hitting the ground, what will be the final velocity of the ball. Now if I calculate that, then I can, with that information, I can calculate the initial velocity with which the ball would travel in the upward direction, because I know it will be 9/10th of v. And further, using that information, you can calculate the time, because then you will know what is the maximum, at the maximum height position, what will be the velocity. So on and so forth, you can calculate it from 0 to 12 seconds, and you can draw a graph between speed and time, right? But there's a lot of calculation involved, so be prepared for it. So I'll make use of this equation. So time taken by the ball to reach the ground, I use this x is equal to x0 plus v0 into t plus half at square, where a is equal to minus g, that is equal to minus 9.8 meter per second square in this case. So x is 0, x0 is 90 meter, v0 is 0, this is minus half into 9.8 t square. I've just substituted the value of a. So if I bring 90 on the left hand side, this becomes minus 90 is equal to minus 9.8 divided by 2 is 4.9 t square, right? So t square should be equal to 90 divided by 4.9. Since I have a decimal in the denominator, I want to get rid of that decimal, and I know there is a decimal after one digit, so I multiply the numerator and the denominator with a number which has single zero, so that I get rid of this decimal. So when I multiply this, this becomes 900 divided by 490. But you have a decimal here, so you keep it from the right after one decimal point. So this becomes 900 divided by 49. So let's simplify how much is 900 by 49 by working out here. So 49 and 900, right? So how do we do this? See, 49 is approximately close to 50. So therefore, 52s will be 100. So I'm just taking 90. So therefore, 49 ones are 49. So 10 minus 9 is 1, and 8 minus 4 is 4, and you borrow the 0, so it becomes 410. So 15 to 8 would be approximately 400. So I will multiply this also with 400. With the 8. So let me check how much is 49 into 8. 8 9s are 72. 8 4s are 32. Plus 7 will be 39. So I can easily write this as 392, right? So this will be now 0, this will be 8, so this will be 10 minus, so 1, then you keep a decimal point, you get 180, right? So you have 180. Now I can multiply this with 3. So let me see how much is 49 into 3. So 9 3s are 12, and 3 4s are 12, 113. So therefore it will be 132. 180 minus 132 would be 10 minus 2 is 8. This becomes how much? 7 minus 3 is 4. So with the 0, with the decimal point, you can borrow one more 0, and then I multiply this with 8 and c. So 8 is 392. So therefore I can easily write t square will be equal to 18.38. So how much is t? That is nothing but square root of 18.38. So now you should know how to take the square root. So I hope you are familiar with this, finding out the square root by division method. If not, I can just teach you it here. So it is 18.38. When you are taking a square root, you group them into two numbers. So this is one group, this is another group from the right side. So now you have to find out a perfect square. We know 2 square is 4, which is lesser than 18. 3 square is 9, right? 4 square is 16. 5 square is 25. So this is appropriate. 25 is a larger number because I just have 18 here. So I take 4 square. 4 4s are 16. And this 4 you add it here to get 8. So you subtract this number. You get 2. You remove the decimal point and take the whole digit, which is 238. Now you have to choose the number in such a way that you get almost. So I will choose, I'll do the working here because I do not have enough space there. So therefore, let me choose 82 into 2. So that will be 416. If I choose 83 into 3, that will be 9 and this will be 24. So this is a larger number. I can't take it. So I take this number, it is 2 and 2 here. So therefore you get 164. So therefore this 2 will be added here and you get 84. This 2 you have to add. So you subtract, you get 2 and then 13 minus. This is 7 and you can further with the point, you can take another 0 and simplify it. But I'll keep it as such as 4.2 seconds. So this is the time taken by the ball to reach ground. So it takes 4.2 seconds to reach ground. Right? With this information, I can even calculate what was the velocity of the final velocity of the ball before reaching the ground. Right? So you can make use of one more equation of motion to find that out. So I will use the next equation of motion. The speed with which the ball hits the ground, or just before hitting the ground, the speed will be v is equal to v0 plus a into t. Again, a we can be replaced by minus gt, right? So v0 was 0. This is minus 9.8 into time is 4.2. So velocity has to be, so let us multiply this and find out how much is the value. 9.8 into 4.2. So it is 8 2s are 16, 1 carry, 2 9s are 18 plus 1, it has to be 19. So 8 4s are 32 and this is 3. 9 4s are 36 plus 3 is 39. So it will be 11 11 4. So you have to keep a decimal after 2 digits. So it is approximately 41.16 meter per second, or approximately minus 41.2 meter per seconds. Now why do you have a minus sign? The minus sign tells you that there is a decrease in the velocity because it is under the action of gravity. The velocity keeps on decreasing. Right? Now using this information, this is the velocity. It took almost how much time? It took 4.2 seconds to reach this velocity. So at 4.2 seconds you have the speed as minus 41.2, or you can just say 41.2. Minus sign tells you that there is a decrease. Now we also know that the ball upon hitting the ground loses 1/10 of its speed. So therefore the initial velocity of the ball is then given by 9/10 of the velocity of the ball. So 9/10 of the velocity of the ball, that is 41.2. You can retain the minus sign. So therefore if I multiply this, which is 41.2 into 9. Therefore 9 2s are 18, 9 1s are 9, plus 1 is 10, 9 4s are 36 and 37. So you keep the decimal point after one digit, so therefore it is 370.8 divided by 10, so that is nothing but 37.08 meter per second will be its initial velocity or the rebound velocity. Okay, they are one and the same, or this can be approximated as 37.1 meter per second. And when is this speed attained? This speed is attained almost at the same time, because almost instantly the ball rebounds at the same time. So at 4.2 seconds it has got 41.2 just before reaching the ground, and just in a fraction of a second it just rebounds, and the velocity loses 1/10 of its speed to gain an initial velocity of 37.1 meter per second, right? So now with this information you can calculate the time it takes to reach the maximum height. So the time that is taken by after it rebounds with this velocity, what is the time taken by the ball to reach the maximum height position? So at maximum height position I can make use of this. At maximum height position I know the final velocity will be 0. The initial velocity is now 37.1, or you can just use it as 37.08 minus 10 into t, right? So this was also minus, so if I bring it on the other side, or you can just keep it as plus. So therefore t will be equal to 37.1, sorry, this is not 10, this is 9.8, right, divided by 9.8. So let's multiply the numerator and the denominator by 10 by 10. So you get 371 divided by 98. Now let's simplify this. This is 98 that you have, and this is 371. So we have to find out how much time it actually takes. Let me multiply it by 3 and find out how much it takes. Okay, so I'll do the working part here. 98 into 3, 3 8s are 24, 9 3s are 27 plus 2, 29. So I can take 3, 294. 11 minus 4 is 7, and this becomes 6. 16 minus 9 is 7, so this becomes 0. I keep a point, I borrow 0, and then I try to multiply it with 8. So I think 8 would be appropriate. Let's check. 8 8s are 64. You have 6 carry over. 9 8s are 72 plus 6. 72 plus 6 is 78. This is a larger number, so I get 3.7. I'll just keep it as 3.7. So t is approximately 3.7. You can do it to 2 decimal places, but I'm just retaining it for single decimal place, right? At 3.7 seconds. So what happens at 3.7 seconds? At 3.7 seconds, the speed is actually 0 because it reaches the maximum height position. This is the time of ascent. So we know total time it takes is equal to the time of ascent plus the time of descent. So t plus ta, how much was t? So initially it took 4.2 seconds to reach the ground. Now it is moving in the upward direction with a speed of, in a time of 3.7. So the total time it takes to reach the maximum height position is 9 and then 7. So 7.9 seconds. So what is the speed at t is equal to 7.9 seconds? The speed is 0, right? So make a note of this. So we have 3 speeds. At 4.2 seconds, 41.2 meter per second. At 4.2, almost, it is 31.7, 37.1. and at 7.9 seconds v is equal to 0. Remember, you were asked to plot the graph for a time interval between t is equal to 0 to t is equal to 12. Now I have to just calculate it for 12 seconds. So therefore, now it takes the same time almost to strike back from the main height. So therefore, to reach ground, time taken by the ball would be 7.9 plus the time it took to come down, 3.7. It is approximately 7 plus 9 is 16, one carry, so 11.6 seconds. So let us calculate the speed at 11.6 seconds. At 11.6 seconds, what will be its rebound velocity? So we can just calculate the rebound velocity, because we know that it is almost equal to v naught is equal to 9 by 10th of v, right? So how much was v? 37.1. So 9 into 37.1 divided by 10. Let's multiply this. 9 ones are 9, 9 sevens are 63, 3 carry, 9 threes are 27 plus 6 is 29, and you have a decimal point. So this is approximately 29.39 or 29.4 meter per second. I hope I have done it right. Have you got it right? Yeah. So 9 ones are 9, 9 sevens are 63, 6 carry, yes. So 9 threes are 27 plus 6, sorry, 27 plus 6 is 34. So I got it wrong. Sorry. So let's correct it and write it as 34.39 meter per second, or approximately it is 34.4 meter per second, right? So when is this speed attained? At 11.6 seconds. So now you know the different speeds at different time. We can easily plot the graph. I'll write them down for your convenience. So this is time. This is the speed it has attained at various time intervals. So I think I have 3 or 4 time intervals, right? So at 4.2 seconds, and then I have it at 7.9 seconds and 11.6 seconds. So 4.2 we have found out it is 41.2, and this is 37.1, this is 0, and this is 34.4. So this is the information you have. Using this, you can easily calculate or easily draw your graph. So you see, it is from 4 to 11, so you can choose an appropriate scale. So I will choose my scale to be starting with 4. Even this is from 34 to 31. I can't plot 1 to 3, so I need a larger page, and it's, so we can just start our graph from 34. So what I do is, so just show that, or even here you can just skip, here you need not show. Let us say 0, and this is 4, this is saying 8, and this is say, I'm skipping 4, 12. So this is your time axis, and which is in seconds. This is the speed, which is in meter per second. See here, I'll skip and I'll just start it from 34, maybe 37, 40, 43. So you can write your scale. What is the scale that I took? X-axis, I have taken 1 centimeter is equal to 3 meter per second. Why 3 meter per second? Because that is the jump from 34 to 37. Here it is 4 seconds. Sorry, this is y-axis and this is x-axis. 1 centimeter is 4 seconds. Right? Now you know the values. Let us just plot. Okay, now at 0 it was 0, so you have 1 point here certainly. Right, at 0 it was 0, then 4.2 seconds it was 41.2, so 4.2 is somewhere here. So this is 40, 41, 40, let's say 42 will be somewhere here. So this will be your point. Also at 4.2 it is 37.1, so this is 37.1 will be somewhere here, right? So you have 1 point here, 1 point here, 1 point here, and 7.9 seconds it is 0, so 7.9 seconds I have to just mark it here, right? And 11.6 seconds it was 34.4, so 11.6 is somewhere here. 34.4 will be somewhere here. Right, now let's just join the dots. So you can take a scale to join the dots. Then yeah, there was a point here, sorry, which is 34.4. So and then that continues, right? So this is the speed time graph from t is equal to 0 to t is equal to 12 seconds. I hope you have understood the numerical. Let me know in the comment section below if you have any doubt anywhere, and I can help you do that. Thank you. Thanks for watching my video.